Hey everybody, this is Games Plus James, and welcome back to our Unity 3D platformer action game exciting tutorial series, where we're going to take a look at moving our player around using the camera. So in our previous episode, we set it up so that we can look up and down with the camera, like that, and we can look side to side as we move around as well. But the problem is, no matter what, if we press up, our player will always go in that direction. So I'm holding up here, but our player is constantly moving in the one direction the whole time, which is obviously not really what we want our player to be able to do. We want our player to twist how it's looking as the camera is looking and follow, so that whenever we are pressing forward, we're going in whatever direction the camera is facing. Another little issue that we want to fix up is if we start looking around sideways and we start looking up and changing our direction and stuff like this, we can see our player is flipping around like crazy and doing lots of weird things which aren't very good for us at all. So that's kind of our major problem that we have when we look at the game in operation right now. So let's fix that first of all. So I'm just going to go back out of here. And the way we're going to fix that is by using a secondary object to act as the point that the camera rotates around when we're looking up and down. So at the moment when we look left and right, we're making the player turn, and then the camera turns because of the player turning. And when we look up and down, the player is also turning up and down, and the camera's following that. But rather than following the player moving up and down, instead we're going to have a secondary child object that's going to act as the point that the camera is going to look at for looking up and down. So the player will always stay standing straight up, and our camera will be able to rotate the way we want it to. So to do that, we're going to create a child object of the camera rather than the player here. So we're going to create an empty object that we're going to call pivot, just as a way to recognize that we're using the pivot point. And the reason we won't use this for turning left and right, only for you turning up and down, is that we want to actually use that left and right to turn our player and move him around within the world, as we'll see once we get to that a little later in this episode. So we have this pivot point, and we need to actually do something with it in our camera script. So we're going to open up our camera controller script. We could open it here, or we could click on the component over here and open it up just there. And if we look in our camera controller script, we're going to need a reference to that pivot point. So we're going to say public transform pivot, like that. And we'll save this and we'll go back into Unity and we'll assign that so that we don't forget to do it a little later. So we'll click and drag our pivot into that slot there. And basically what we want to do is, we know that this pivot point, we want it to be wherever the player is. So we're going to point this at we're going to position this pivot point so that it's where the player is, and the camera will know to look at that. So if we go back into our script, basically in our start function, we're going to say, okay, take that pivot and set its transform dot position to be equal to the target transform dot position. So it'll go to wherever the target is within the world. And we also want to set pivot dot transform dot parent equal to the target transform. So what that'll do is it'll say, okay, as soon as the game starts running, move the pivot to wherever the player currently is, and then straight away make the pivot a child of the player. So that way when the player moves within the world, the pivot point will move along with the player. So let's just see that. If we save this and go back in here, we see the pivot is a child of the camera and it's a child of the player. And it's not a child of the player. And then we press play, it switches so that now it's no longer a child of the camera, it's a child of the player. And the reason we do this is, rather than just setting it by default to be a child of the player, what if at some point as we go further on we want to switch to a different object to use as our target? Well, we can just set the pivot to be a child of whatever that new object is. So we know that once we know that we can do that, we can just do it going forward at any other point in the game. So we have that in place. Actually, I'll just show, obviously, if we move the player around within the world like this, our pivot goes around with him. You see by this the 3D kind of controller there. So you can see the pivot point is always moving around with the player. So perfect, that's exactly what we wanted to do. Let's go back to our script. And so in here where we're getting the X position and we're rotating around the target, instead of doing the same for the Y, what we're actually going to do is we're going to get the Y position of the mouse and rotate the pivot. Nice and simply, a little bit more straightforward. So here we will keep this our vertical kind of rotation stuff that we worked out, but instead of doing target.rotate, we're going to do pivot.rotate. So that'll allow us to only be rotating the pivot point, and now our camera can be we want a camera to take the rotation from the pivot point and apply it to the camera itself. So we've taken here the we use the desired X angle because we remember we had to use the X position to control the Y movement of the mouse. So we want to get the desired X angle. Instead of going to target.Euler angles, we're going to go to pivot.Euler angles. So let's save this and go back into the game. Let it compile for a second, and now if you press play, we go back down here. We'll see we can move our camera up and down all we want, and our camera in the top up here on the scene view up here, we can see that the player isn't being rotated up and down at all, which is perfect. That's exactly what we want. So now we don't have this weird case where the player looks like he's kind of moving around all over the world. Okay, so now we've got our camera a little bit more sensible, a little bit more not quite as broken, basically. But we don't want to have this mouse on the screen the whole time we're playing our game. That really doesn't look like something that we really want to do. So we want to make sure that we can hide this cursor as soon as the game starts running. So what we're going to do that is a very simple command built into Unity. We can just say cursor, and we want to do this in the start function because we want it to happen straight away as soon as the game starts. So we'll say cursor.lockState equals cursor lock mode dot locked. So all these things are, so cursor, pretty self-explanatory. We're talking about anything related to the mouse pointer itself that we're waving around here. Lock state means whatever kind of locking we are applying to it. That can do things like we can, if we read a little description down here, we can set the hardware pointer to be locked to the center of the view, constrained to the window, or not constrained at all. And what we're doing is we're locking it to the center of the view, which will also hide it visually. So to set a lock state, we have to use a cursor lock mode, which decides, hey, we're going to do a lock of some kind, and the type of locking that we want to do is lock the cursor to the center of the game window. So let's save this and go back in here and see it in action. If we press play now, straight away our mouse disappears. We see no matter how much I wave this around now, our mouse is gone. And all that we're actually doing now is controlling the camera within the world. And obviously it feels a lot better to be just controlling the camera in this way. So perfect, we've got that. Now if we want to actually do any changes in Unity while we're here, if we hit the escape button, it'll automatically make the mouse reappear. You can see the game is still playing. They're still moving the camera around, but it makes the mouse button appear again so that we can go ahead and edit any changes we want to do, or of course, we can stop the game running. Okay, so now we're rotating the player and we're rotating our pivot point to look up and down. So let's go ahead and actually base our player's movement based on whatever way he's facing. Now, one of the really handy things built into Unity by default is a way that we can actually apply forward movement or left and right movement based on the rotation of the player himself. And if we go and we look at our player controller script, I have it open here already, but if you don't, make sure we open it up from here. And at the moment we have our move direction being set by whatever horizontal input multiplied by move speed, and whatever vertical input, again, multiplied by move speed. We're not going to use that anymore. We're going to write a new way of sorting out our move direction. And what we're going to do is we're going to say move direction equals transform dot forward. So transform dot forward will basically apply whatever direction the game object within the world is facing in. It'll transform dot forward will be represented by the direction it's facing, kind of abstracted from a rotation back into a vector tree value that we can use. So what we're going to do is take that transform.forward and we're going to multiply it by our input. So input dot get axis, and the axis we want to use is our vertical axis, because any forward input is when we're pressing up and down, or W and S on our keyboard. So if we put any vertical input in, we're going to multiply that by transform.forward, which is whatever direction we're facing forward, and we're applying that to our move direction object. So if I go ahead and just put our semicolon in, and now we save it, if we go back into Unity and we'll press play and we rotate our camera around, if we press forward, our player is actually not moving very fast because we haven't multiplied by a move speed, but we can see our player is now going in the direction that we face our camera. Let me just go back and very quickly, we're going to multiply this by move speed for a second, but we'll have to do a little fix where we take that out in just a little bit, but we'll see why once we get to it. So if I multiply by move speed, now we go back in here and we start moving our player around. There we go, we're moving a bit faster, but all I'm doing is holding forward, and we can see our player is going forward in whatever direction we face him. So perfect, that's exactly what we want. We can also go backwards because our movement will take us backwards and forward. So that's why transform.forward is really handy, because it just basically works out whatever direction we've rotated our player to face. Hey, the forward is the logical forward movement of the player. So that's perfect. So let's do the same for moving left and right. And what we're going to do is basically add any left or right movement onto our move direction. So we have our transform.forward multiplied by input axis vertical. So let's here add on transform dot right. So transform dot right is what is represented by the left or right movement of the player. So transform dot right multiplied by input dot get axis horizontal, like so. And again, we're going to multiply that by our move speed, like that. We'll save this and we'll go back in here, let it compile for a second, and we press play. And now if we move left or right, we're able to move like that. We move forward and back, perfect, and we get our rotation around like this. We can our jumping is a little bit off at a second, but we've got everything kind of going the way we want it to, so that's perfect. We'll stop this and we'll go back in here, and actually yes, I was supposed to demonstrate this. So if we are moving back and forward like this, and we can move left and right at our move speed, if we move forward and then start moving left at the exact same time, we actually move kind of twice as fast in that direction. You can see everything goes by really, really fast, but if we were to like move forward or move left, everything doesn't quite go as fast. So we don't want our player being able to, basically, you can kind of game the system and start running around super duper fast by running in two directions at once. So that's obviously not what we want to do. And to fix that, we use a thing called normalizing. So what we're actually going to do is take out the move speed out of here. Like this. And we're going to say move direction equals move direction dot normalized. So what dot normalized does is, if we imagine, let's just say for a second, if I just open up this and we'll draw a quick little thing. So if we've got a pencil here, so the way we were doing it is we have our X and our Y axis like this, and if you press, say if you pressed to the right, you're going to 1 here is the maximum, and if you press forward, you're going to 1 here is the maximum, and if you press both of them the exact same time, then you're going to here. You're going right 1 and up 1, so you're going at this speed here. Basically what normalizing does is it puts this on a circle, so that if you press right 1 and up 1, your speed will actually be a value kind of around here somewhere. So it won't be a full number on either axis. It'll be, say it'll be like 0.75 to the right, 0.75 up. But what it means is we get actually a smoother kind of movement speed, and it is a more logical and kind of sensible way of doing it, and it eliminates our players running around at uncontrollable speeds basically. So now that we have that worked out, we can actually multiply this value here by our move speed. Not move direction, we want to multiply it by move speed. Like so. And it's given an error. Why have we got an error here? Oh, because for some reason I typed in move speed here. This should be move direction, because we're making changes to our move direction. We're saying our move direction is equal to move direction.normalized, because we're normalizing this variable here, and then we're multiplying that by our move speed so that we know our player can only go at a limited amount of speed in a diagonal direction basically. So we'll save this, pop back into the game here, let it compile, and there we go. Now we can run around, and if we move diagonally, we're not going any faster than if we were going just straight forward and straight left or right. Okay, perfect. So one other little thing that we want to fix up is what happens when we look up in the sky like that. So our camera passes through the ground, which is obviously, that is not really what we want happening on our player. We want our camera to be we don't really want it going through the player, through the ground like this. Now we're not going to worry too much about the camera just yet clipping through these objects in the world in general. That's okay. It's not really the worst thing. It's something that we can deal with at a later date when we go more into how a camera can work. Our falling is going a little bit slow at the moment, but that's okay. We'll take a look at that in a bit. But we want to fix up what is happening with this camera. So to fix up our camera going through the ground, basically all we have to do is say that the camera can't go below a certain position within the world. So to do that, what we can do is go back into our camera controller script, and down here, before we look at the player or anything like that, we'll just say if the transform dot position dot y, so that's the y position of the camera, if that is less than target dot position dot y. So basically, if the camera goes below the height of where the player is within the world, well, in that situation, we want to make sure, okay, don't do that, because we don't want it to go down below the player, or specifically down below the world. So we'll just say transform dot position equals new vector tree transform dot position dot x, because we don't want to change anything on the x-axis, but on the y-axis we want to set it to be target dot position dot y, and then on the z-axis we'll leave that to whatever it should be, transform dot position dot z, like so. So we can save this, go back in, press play, and now when our camera goes down, instead of going down through the world, what it'll actually do is get closer to the player, like this. So that it looks a little bit better, it looks a little bit more sensible. If we wanted this to, if we wanted the camera to be allowed to look up a little bit more than this, what we could do, because we know our player is too high within the world, and the central position of the player, if we just stop playing the game here for a second, the central position of the player is, we have it, oh well, it's floating above the ground there a little bit, but when the player is touching the ground, it's at 1 within the world, like that. So we can say, okay, well, we don't want the camera to go through the ground, but we can allow it to go down a certain amount below the center of the player. So let's say we could do, instead of going to target.position.y, let's set it to target.position.y minus 0.5f. So we'll go not quite to the ground, but a little bit lower than the center of the player. So if we press play, and now you can see the camera is a little bit lower than the player, and we're actually able to look up in the air a little bit. And as we get closer, we're able to look up a little bit more. But we're not going too close, and we're not going below the ground in any way. So perfect, that's exactly what we want that to do. So let's just stop this running here. And the next thing we want to do, actually, I should have left this running. We want to fix up one little thing now. So now, when we move around through the world, if we jump, we're back to having this weird kind of jumping that we had before that wasn't really quite right. And if we walk over the edge, we're slowly falling down, which is obviously not what we want either. And that's because we made a slight little change of how our input on our player was happening. So if we go back to our script and we look at our player controller script, if we look, what we did was we've applied this new type of move direction, which are transform.forward and now transform.right. And when we're normalizing that, that's kind of messing with the y direction of wherever our player is going within the world as well. Because if we look at our MS Paint thing, so we were talking about the X and Z values when we're talking here, but also if we imagine there's a third axis coming up this way, then this one will be limited to going one up in this direction as well. So if we're supposed to be falling down faster than that, it's getting limited and it's kind of messing around with it. So to fix that, as kind of a bit of a workaround for that basically, is before we do, we're applying this new movement type here. We're going to create a new value called float y store, which is going to store whatever y direction we currently already have. So we'll say float y store is equal to move direction dot y, like this. And then after we work out our movement, well, then we're going to say, okay, now that we know what that is, y store, or sorry, not y store, move direction dot y is equal to y store. So we're basically applying whatever up or down movement we already had worked out previously to back to our player. So we'll save that, go back in here, let that compile for a second, press play. And now when we jump, we're back to jumping like we should be. And when we walk over the edge, we're falling down just the way we should. So there's one other tiny little quirk that is going to take just 1 second to fix up as well. And that is when our player moves, our camera, if we look at our player, it looks like he's kind of jerking around a bit. If I just tap movement, our player is kind of jerking around as we move. And that's because of the order of when our player, the script of our player sometimes gets called before the script of our camera. So the player moves and then the camera has to catch up on the next frame basically, which is kind of confusing. But we could go around, there's a whole script execution order that we could go and mess around with in Unity. But rather than complicating that stuff for ourselves, what we'll do, if we stop the game here, we'll switch over to our camera controller script. And here, where we have everything happening in update, instead of it happening in update, we're going to set it to happen in late update. So late update, if you can't imagine just by guessing from the words, late update happens after update. So every frame of animation, when our game is running at 60 frames or whatever, before it moves on to the next frame, after update has happened, it calls late update. And this is basically for stuff like this with the camera and a few other little minor things you might want to do. It's a way of catching things so to make sure that it always happens after something else happens. So we always want to, after the player has moved, then we'll move the camera because we know where the player should be within the world. So we let that compile back in the game, press play. Now if you move around, if I just tap, we can see it doesn't look like the player's jerking forward ahead of us. It actually looks a bit more smooth and a bit more sensible. So there we go. Now we've got pretty much all the basic movement of our player worked out within the world. We're able to jump around like crazy, and we're able to basically move and look wherever we're going. So that's the basic movements of our player, and we're going to return in the next video and start adding some more kind of gameplay things into the game. So make sure you come back next time for more 3D action platformer goodness. Thanks for watching, and I'll see you all very soon.